Introducing our eighth presenter from Grouping 1, Science and Health, Dr. Jeremy Drake from Victoria University, whose title is Turning Genes Off as a New Way to Treat Breast Cancer. When you're ready.
Breast cancer is the most common form of women's cancer. 1 in 8 women will be diagnosed with breast cancer before they reach 85. Today, 42 women in Australia will get the diagnosis of breast cancer, and that means that over the course of this year, there will be over 15,000 new diagnoses of breast cancer here in Australia and over 1.8 million around the world. Current treatment strategies for breast cancer include surgery to remove the cancerous tissue, as well as chemotherapy to try and kill any cancer cells that have spread to other parts of the body. Unfortunately, chemotherapy has some pretty nasty side effects, and despite improvements in treatment, breast cancer is still the second leading cause of cancer-related death in Australian women. So obviously, research into new treatment strategies is important. Fortunately, this is quite a difficult process, and one of the reasons behind this is because cancer cells behave in a very different manner to normal body cells. They have changes within them that essentially give them superpowers. They're able to behave in a different way to normal body cells. One of the factors implicated in giving a cancer cell these superpowers are a group of proteins which are called heat shock proteins. These proteins get their name because they're made by a cell in response to stress, like heat, for example. But they can be produced in response to any kind of stress, maybe not enough oxygen, or being exposed to a toxic drug, for example. So what happens when a cancer cell receives this stress is it will produce these heat shock proteins, and the heat shock proteins allow it to repair any damage that it has sustained in response to this stress. And by doing that repair, it can continue living and growing in this difficult environment. Now, because heat shock proteins are associated with breast cancer survival, what we're doing in this research is looking at a specific gene associated with heat shock proteins called the HSF1 gene, or heat shock factor 1. And it's essentially a master switch that switches on the production of heat shock proteins. So turning on this HSF1 master switch will increase the production of heat shock proteins. Now I want to show you a really interesting result that's come out of this work so far. What we've done is taken cells out of the breast and we grow them in the lab. We're looking at them here under a microscope. You can see we create a wound in those cells and we watch over time as the cells grow together and heal that wound. You can see they're coming together here and healing that wound there. We've done this with both normal breast cells, you can see there at the top, and also breast cancer cells. Here on the left, the normal breast cells, you can see they don't grow very effectively. Over the 15 hours which we watch them, they don't heal that wound very well. If we switch on that HSF1 master switch, increasing heat shock proteins, you can see that nothing really happens. They look identical to the normal breast cells. If we look at what happens to the breast cancer is cells proliferating much more rapidly, so they heal that wound much more effectively. But what's really interesting is if we look here on the right, when we switch on this HSF1 gene, the cell proliferation is massively increased and they completely heal that wound over the 15 hours. And this is exciting because what it means is that turning on the HSF1 increases the growth of breast cancer cells without having any effect on the normal breast. So it could have the potential to be involved in some kind of therapy. So what we want to do next then is see if we can do the reverse. Can we turn off this master switch, turn off the HSF1 gene, and therefore reduce the production of heat shock proteins? If we're successful in doing this, in turning off the HSF1 gene, this could be really exciting because it could lead to new targets not only for the treatment of breast cancer, but for other cancers as well. Further down the track, what we're hoping to do is see whether we can switch off the HSF1 gene in early stage tumours, stop them from progressing to later stage, more aggressive tumours, which are associated with a much poorer prognosis and survival rate, and also see whether we can identify any molecules or substances which can specifically target the HSF1 gene and switch it off, because we could use that as in the development of some kind of novel therapy. So, in conclusion, this is important research, and the reason for that is it can benefit all of the people we love, our mothers, sisters, daughters, and our friends. For me, the 1 in 8 women affected by breast cancer was my mum, who died from this disease in 2003. Who will it be in your life that will be affected? Thank you.